Good day everyone. Today we're gonna prove to you the Taylor's theorem. First of all, I'm Karen, and yes, Taylor's theorem. What is Taylor's theorem? Taylor's theorem is established in order to determine the condition under which a Taylor series will represent a given function. So Taylor's theorem states that if f of x and its first n derivatives are continuous and single values in interval a less than x and x is less than b, then f of b is equals to f of a plus b minus a f prime a plus b minus a squared over 2 factorial plus b minus a over n minus 1 factorial f n minus 1 a plus the quantity of b minus a to the nth power all over n factorial f of n x of 1, where a is less than x and x is less than b. Let's start proving this by letting Rn, the remainder, represent the remainder defined by the relation f of b is equals to f of a plus b minus a f prime a plus b minus a to the n minus 1 all over n minus 1 factorial f n minus 1 a plus Rn. In order to determine the value of Rn here, let us define the function p ab by the relation Rn is equals to b minus a to the nth all over n factorial p, and write down the auxiliary function f of x is equals to f of b minus f of x minus b minus x f prime x minus b minus x and to the n minus 1 all over n minus 1 factorial f of n minus 1 x minus b minus x all over n factorial p, which is formed from this by changing a here to x. If you'll notice, we change a here to x in all terms except the p. It follows from 2 that f of a is equals to 0, and from here, from the third one, that f of b is equals to 0. Hence, in according with Rolle's theorem, f of x must be 0 for some value x between a and b. With differentiating this to x, we observe that all terms except the two except these two, all terms except this one is cancelled. Let's see. F prime x is equals to negative b minus x all over n minus 1 factorial f n x plus b minus x n minus 1 all over n minus 1 factorial p. Substituting in 4 here, the value of x to x sub 1, for which f prime x sub 1 is equals to 0, we obtain f of n x sub 1 is equals to p. Hence, we obtain r sub n is equals to b minus a to the n all over n factorial f n x sub 1, where a is less than x sub 1 and x sub 1 is less than b. That proves the theorem.